flex tool. See, in the experiment number 2, we have already designed lexical analyzer, but we have written a code for that. So hard-coded programming we did in the experiment number 2. But in the experiment number 10, we are going to learn a tool called Flex, which is used to generate a lexical analyzer. Okay, so the objective of this experiment is to make aware about Flex tool, installation of Flex tool, and the basic program structure in a Lex language. So at the end of this practical session, you will be able to design a lexical analyzer using Flex tool to generate a sequence of tokens for a given input. So let us see working of Flex tool. So Flex stands fast lexical analyzer generator, and this tool is basically designed by Faxon in C around 1987. So the role of this Flex tool is to generate a lexical analyzer, and once the lexical analyzer is generated, the next task is to generate the sequence of tokens. So how to install the Flex tool in the Linux environment? You have to first write a command of update sudo apt-get update. So the new packages are get updated, and afterwards you have to provide this command to install the Flex tool. So this figure shows how Flex tool will help to generate the lexical analyzer. In this figure, the very first box indicates a Lex compiler. So you need to write a program in Lex language, like C language. Here, you need to write a program in Lex language. Okay. And you have to give it to the Lex compiler. And once the compiler, Lex compiler generates lex.yy.c, which is C language. Actually, lex.yy.c is a C language or the code or C source code. After that, C compiler generates AUT file, and here you are going to provide the string, okay, right? String along with this uh, a.out file, you need to provide a string, and based on that, the sequence of tokens are get generated. Okay, let me repeat the steps. The very first step is what? You have to write a code in Lex language, right? And you need to give it to the Lex compiler, right? And Lex compiler is going to generate a C code, and that C code again it is given it to the C compiler. C compiler generates a.out file, and here you need to provide a string if you want to provide a string, or you can give explicitly mention in the file itself. Okay, so there are again two ways. So whatever string you are going to provide, the sequence of tokens are get generated. Okay, hence you need to understand the Lex language here. Okay, so what are the steps in the in this Flex tool? So the input file generally describes the lexical analyzer to be generated, and it is named as lex.l, and this lex.l is generally written in Lex language, like we write a program in C language, and when we provide a extension as .c. Similarly, the Lex is a kind of language. In that language, you need to write a code, and that code generally describes a lexical analyzer. And obviously, a lexical analyzer is a kind of program. See, so this lex.l indicates a lexical analyzer code. Obviously, as the language is Lex, you need to give it to the Lex compiler. Okay, so the C compiler again, once the this Lex compiler generates the lex.yy.c, which is C language code, again it is given it to the C compiler. And C compiler generates executable file a.out, and the output file a.out, again it takes stream of input characters and generates the stream of tokens. So let us try to understand the Lex language. So Lex language has generally three sections. The very first section is called definition section. So in this section, we are going to define variables. We are going to declare the variables. We can initialize the variables. Okay, we can also write few preprocessor statements in the definition section. Okay, so here we are going to declare the variables, regular definitions, constants. Okay, and the syntax for this definition section is there must be the percent and opening curly bracket. Again, there is a percent and closing curly bracket. So inside this, you need to provide those declaration statements. In the second section, is generally called as the rule section. Here you need to define the rules. Okay. It starts from percent, ends with percent, and inside this syntax, you need to provide a rule in the form of pattern and the action. Okay, pattern and the action. Fine. So pattern, suppose let me write it down something like suppose A, like this. Suppose A to J. Okay, if this would be the pattern, means if the capital letter is matched, what action is to be taken is mentioned immediately in the curly bracket. Okay, like this. So I'm going to just print f. Okay, percent C, or I'm going to just print yes, capital letter, capital letter, like this. Okay, those, so this indicates two. If this particular pattern is matched, if the entered character is capital, let us say A, this particular pattern is matched, against which this action is taken. So that particular character or the message will be printed that the entered character is a capital character. So in the rules section, we are going to follow this particular syntax, pattern and action. So whatever pattern is going to be matched, if that particular pattern is matched, the associated action will be carried out. So what kind of patterns are there? If the pattern is like 0 to 9, so this indicates 0 to 9, all the digits between 0 to 9 is get matched. 0 plus 9 means here either 0, either plus or either 9 is get matched. 0 comma 9 means either 0 or comma or 9 will be matched. 09 means either 0, this single code, or 9 will get matched. Then this particular pattern indicates all other characters except uppercase letters will be matched. This indicates either AA, triple A, or 4A, means A is followed by single A or double A, or there are three A's after A. Okay, so this pattern will be matched. This dot indicate any character except new line character will be matched. A star means zero or more occurrences of A will be matched. A plus means one or more. A to Z indicates all lowercase letters are get matched. A to Z and again capital A to Z. Any alphabetic letter will be matched. And like this, we have the list of patterns and its meaning. Third section is user code section. In this section, the user can write the C statements or additional functions. Okay. So let me explain the three sections again. So in the language, there are basically three sections. The very first section is definition section. In the definition sections, we can just write the declaration statements. We can just write the variables, declaration of variables, initialization of variables. Okay. The second section is the rules section, as we discussed in the earlier slide. Here we are going to mention the pattern and actions. If particular pattern is get matched, which action will be carried out. Next, the user code section. Here we shall simply write down the C language statements. This is third section. So second, and this one is a third section. Let us try to understand one simple example. The program is to count the number of characters in a string, right? So in the definition section, I have declared one count variable. I have initialized that variable with 0. In the rule section, what I have mentioned, I have mentioned two patterns. See here. The very first pattern is I'm just counting the number of characters in the string. Let me make a modification. Count the number of capital characters. Okay, capital characters in a string. So if this pattern is get matched A to Z, it simply takes one action. And what is that action? Print %s capital letter y text. Now this particular variable is a part of that lex program. Okay. So whenever you are going to print, means whenever you are going to print y text, it simply prints the the whatever pattern, whatever character is matched over there. Means suppose B is matched, then B is a capital letter and it will be printed on the terminal. And again, I have incremented the count variable. So once the pattern is get matched, once the capital letter is matched, the counter is incremented by 1. Else, in the second case, second pattern is if whenever I am going to enter the key, whenever I'm going to hit the enter key, against which it simply returns 0 and the program will be ended. So there are two possibilities. Means I have explicitly mentioned two cases over there. The very first case is what? To match the capital letter. And second case is to what? Once I hit the enter key, the program must stop. Yes. So I have mentioned return 0. Return 0 means here the program will be ended. Let us try to understand this function YY See, the use of YY function is it simply maintains the track of strings, means whatever input string you have given, whether all the characters in the strings are over or still the few characters are remained or yet to be remained to process. So here it returns 1 if you done, means everything, all the characters are read, then it simply returns 1. If few characters are remained and still more characters are there yet to be read, then it simply returns 0. Okay. Next, in the this is what the this part is generally called as user section, user code section. Okay. This part is generally called as rule section, and the very first part is called definition section. Okay. So in the last section, we may write a C language code. So I have created one main function. Inside the main function, there is a one program, there is a one procedure called YYLex. And the YYLex is a initial point for the Lex program. So it is a main function of Flex tool, which actually runs this particular rule section. So whenever we compile the code, the control goes to yylex, and from yylex it goes to the rule section, right? And then it try to match the pattern. Once the pattern is get matched, associated action will be taken. So let us see the input. If you give the input like G12, what would be the output? Yes, number of capital letters is 1. How many capital letters are there in this pattern? Only 1. How many capital letters are there in the string? Only 1 capital letter is there. So the count will be the what? 1. Because I have just displayed the count in the main function, that number of capital letters is %d. So here the count will be displayed. So let us see the steps of program, how we can execute stepwise. The very first step is to write a code in a lex language. Okay. Save that file with extension .l or .lex. Okay. There are two variations. And again, you can simply run the code by following the list of commands. The very first command is lex filename.l or lex filename.lex. Okay, after that, once you provide this file to lex compiler, lex is a compiler, right? Like GCC is a compiler. And what is a file name? File name is a code written in lex language. So after compilation, this particular lex compiler generates lex.yy.c, which is C code. And again, we are going to give it to the GCC compiler. GCC compiler generates executable file ./a.out. And then if you want to provide a program, if you want to provide any input, then you can just provide the input to the program if it is required. Okay. Now let us see the demonstration part. I'm going to demonstrate two programs here. The very first program is to find the number of capital letters. So let me open that file first. Okay, let me open here itself, nano. C.lex. So you can see the code. The very first section is I have declared one count variable which is initialized with 0. Okay. Then I have declared I have created two patterns. The very first pattern is to identify the capital letters in the given string. So once the first letter is identified, count is incremented by 1. Okay. And once I enter the hit command, hit key, then once I hit a enter key, it returns a 0 and the program will stop. Okay. Likewise, you can simply write down the code. Okay. Now let me show you all the steps. First, you need to install the flex command, sudo apt get flex, sudo apt get install flex. So before you just compile a code, you need to first install the flex tool, and then you need to follow the following commands. The very first command is first lex c dot lex. Okay, fine. After that, once you compile this file, let me first remove those files. Remove lex dot, and also I'm going to remove. Now in this current directory, you can see only one file with extension lex. Okay, now let us try to compile the lex file. So lex is a compiler, c dot lex. Once I compile this file, one c file will be generated, lex.yy.c. Now I'm going to compile this c file by using gcc compiler. And once I compile this file, you can see the executable file called a.out. Now I'm going to run this code dot slash a.out. And now here I'm going to provide one string G12. See what output is displayed over there. Here G is matched, means this particular capital letter is matched, pattern is get matched, and whatever the action is given, what action I had mentioned there, G is a capital letter, right? And the number of capital letters in the word is 1. Okay, so here the letter is matched and count will be displayed. Let me provide one more input. Mm, so here you can see A is a capital letter because this pattern is get matched. B is again a capital letter. C is a capital letter, and finally the number of capital letters in the word is 5 will be displayed. So let us try to understand one more program. Count count the word. Okay, let us see. I'm going to provide one sentence, and the output should be the what number of uh, words in the sentence. Let me remove this two files, a.out, lex.yy.c. Okay, now you can see only one file is there in the current directory. Let me just compile this file. Lex is a compiler. The file is lex.l. Once I compile the file, lex.yy.c file is get generated. So I'm going to again give it to the lex compiler, and after that a.out file is get generated. So let me compile this file, and let me provide the input string, means a string that I'm going to provide. So hi, how are you? Okay, so what output is displayed? Yes, how many words are there? So there are 4 words, and the count will be displayed as 4. If I give D, Y, P, C, E, T and me, 3 count will be displayed like this. This is TY class. The 4 count will be displayed. Like this, you can just write a code in the Lex language. So you can simply design a lexical analyzer. Okay. So this is all about the experiment number 10. Thank you. Okay, now your task is to just implement